We stopped here yesterday, just shy of finishing this, I think. We have find the exact value of each of the remaining 5 trig functions if we know the tangent of x is 4/3 and the x is in quadrant 3. X is an element of, remember that set notation thing, x is an element of quadrant 3. All right, now what we have to remember when we sketch this triangle, it's trig, so we're always playing the where is the triangle game. It's in quadrant 3, we're given that. And we have to remember that as far as directionality, left and down are negative quantities. So left and down are going to be negative here, which means both legs of this triangle are going to be negative. And opposite over adjacent is going to be 4 and 3. Negative 4 and negative 3. Which means negative divided by negative will still be positive. I need to make silent chip bags. You know, that's a great invention idea, right? Ziploc bags. Silent chip bags. And silent chips. You have every family has one person that if you eating chips, it gets on their nerves. Right? At least one person. If your family doesn't have that person, then it's you. All right. All right, so 3, 4, 5 is the triangle. We finished this yesterday, didn't we? 3, 4, 5 is our triangle, and the trig values are this. Okay, so look back at the six examples that we did yesterday. We're going to kind of make some observations. The first problem we did was a first quadrant angle and reference triangle, right? What did we discover about all 6 trig ratios in the first quadrant? They're all positive. The second quadrant, what did we discover? Only the sine is positive. Yes. In the third quadrant, we have only the tangent positive. Is that correct? Looking back. And then we haven't done a fourth quadrant angle at this point, but what do you think is going to be our positive trig function in the fourth quadrant? Cosine is positive in the fourth quadrant. And there he is. If you turn the page of the note sheet there, you'll see a little blank thing at the top. They're all positive in the first quadrant. The sine and its reciprocal are positive in the second quadrant. The tangent and its reciprocal is positive in the third quadrant. And the cosine and its reciprocal are positive in the fourth quadrant. Extremely important that you know this cold, and I've heard some of you kind of saying it already. All students take calculus. ASTC is, that's an acrostic you can use for it. But we can use this information, and we will use it all the time. All right. In trigonometry, we're always measuring triangles and putting that triangle, reference triangle in the correct quadrant is going to be of the utmost importance. All right. So, in which quadrant, this next question says, in which quadrant must the terminal side of an angle lie in order for the sine to be positive? Quadrant 2 or 1, right? The sine is positive in quadrant 1 and quadrant 2. Okay, and what that means for us from an angle standpoint, and we'll get to this, kind of more, that the sine is positive from 0 degrees all the way up to 180 or pi radians. Okay, what kind of angles are between 0 and 90 degrees? Acute angles, right? What kind of angles are between 90 and 180? Obtuse, right? So the sine function, y'all listen, the sine ratio of all acute and all obtuse angles is positive. Okay? That's going to be tricky for us when we start solving triangles. And I'll tell you why when we get there. Okay? So 0 to 180, the sine is positive for 0 to 180, first and second quadrant angles. Okay? What about, next question, in which quadrant must the terminal side of an angle lie in order for the cosine to be negative? If we want the cosine to be negative, what quadrants are we dealing with? Quadrant 2 and quadrant 3, right? If the cosine is negative, then we can't be here or here. Cosine is positive in both those quadrants. So if the cosine is negative, we're talking about an angle that is in the second quadrant or the third quadrant. Okay? And that means the terminal side of the angle is there. We could get there by going backwards. We could get there by going forward 6 times and ending up there. Okay? As long as you're in the second or third quadrant, the cosine is going to be negative. Okay? Next question. In which quadrant must the terminal side of an angle lie in order for the cotangent to be negative? What do you think, Peyton?
2 or 4.
2 or 4. The cotangent is negative in 2 or 4, right? Because it's positive in 1 and 3. So those 2 quadrants are eliminated. So if the cotangent is negative, then we're going to be in quadrant 2 or quadrant 4. So again, 2 quadrants, right? How many quadrants did the first problem have? It's 2 quadrants, right? Second question in this section, 2 quadrants. This section, 2 quadrants. We want to know 1 quadrant, don't we? Okay, so that's going to be important. We need more than 1 piece of information in order to get an angle in the correct quadrant. In which quadrant must the terminal side of an angle lie in order for the secant to be positive? Taylor, what do you think? Where is the secant positive? 1 and 4, right? Secant is negative in the second and third quadrants. All right. So if secant is positive, then we know we're in quadrant 1 or quadrant 4. That's where our angle is going to lie. Okay, the terminal side of the angle has to be in that. All right, so we're going to use this information to answer some more questions. Now, our quiz on Thursday is going to come from questions like the questions in this packet. We're not going to do degrees to radians or radians to degrees, even though that's going to be on the test. We'll review that again before that. The quiz on Thursday is just on these types of questions that we've worked in class yesterday and today. This says find the exact value of each of the remaining 5 trig functions if sine of x is negative 3/5 and the cosine of x is greater than 0. Cosine x is greater than 0 is another way to say what? Cosine is positive. All right, so if the cosine is positive, which quadrants can we toss out? We can take out 2 and 3. Cosine's positive in quadrant 1 and quadrant 3. So how are we going to eliminate one of those? Because I'm not going to draw my triangle in 2 places. I'm going to draw it in 1. How do I know which one it is? Quadrant 1 or quadrant 4? Why, Holt? The sign is negative, so it can't be quadrant 1. All right, the sign is negative, it can't be quadrant 1, which means our referenced angle and referenced triangle have to be in the 4th quadrant. Okay, now the reason I'm calling this a reference angle is because I really don't know what the angle is. I just know where the terminal side of the angle is based on the given information. All right, the angle is a 4th quadrant angle. It may be whatever that angle is, negative 60 degrees, negative 70 degrees. I don't know what it is. Or it could be 310 degrees, or it could be 670. We don't know the exact angle. We just know that its terminal side is there, and it has a sine value of negative 3/5. Got to always remember, down and left are negative directions, up and right are positive directions. So negative 3/5, and the adjacent side is 4. Right? So the cosine of this angle would be It's kind of never a bad idea, guys, to put this into play. All right. If you put that down, then you can check your answers and make sure that they make sense. We're given that the sine of x is 3/5, negative 3/5. So the cosine of x is what? Emily Barnes, what's the cosine of x? You don't know? We'll have a look. Cosine of x. Megan? 4/5. It's the adjacent side over the hypotenuse. Here's the adjacent leg to the angle, and there's the hypotenuse. All right, so it's the adjacent side over the hypotenuse. Tangent of x would be what, Georgie? Negative 3/4. And then from there we can do our reciprocal functions. Cosecant of x is negative 5/3. Secant of x is 5/4. And the cotangent of x is negative 4/3. And if we've done this correctly, this is why I was saying it's a good thing to put the ASTC down. It's a check for us, right? Only cosine and secant should be positive, and that's the case. Cosine is the only angle that should be positive in the fourth quadrant. Okay, quiz on Thursday. All right, try the next one on your own, number 12. Get started on this one and we'll finish the next couple up together. Ah, man, I didn't mean to end that. So we have to remember this is trigonometry, right? We're measuring triangles. So we've got to put the triangle in the correct place, label the triangle correctly, and then answer the 6 questions, the 6 trig ratio. Because we're told that cotangent is negative, that eliminates the first quadrant and the third quadrant, right? The other piece of information that we have to get the triangle in the correct place is that the cosine is also negative, and that eliminates quadrant 4. Because all students take calculus. So we need the cosine to be negative and the cotangent to be negative, and that's going to put us in quadrant 2. So there's my right triangle. The adjacent over the hypotenuse makes this negative 2, makes this positive 3. And we find this third, the other leg, by using the Pythagorean theorem. Negative 2 squared plus b squared equals 3 squared. That's positive 4 plus b squared equals 9. Subtract 4, take the square root, and we get b equals just the positive root of 5, because we're talking about a distance here. So this is the square root of 5. And then we can answer all the questions. Sine x equals square root of 5/3. We can go ahead and do the cosecant x while we're here. 3 over the square root of 5. Cosine x, we're given. Cosine x equals negative 2 over the square root of 3. And that means the secant of x is equal to negative 3/2. Tan x equals the opposite side over the adjacent side. So that's negative, is the square root of 5 over negative 2. And the cotangent is negative 2 over the square root of 5. Okay? Better? Good? All right, one more. Try 13 on your own. Move on to 13. Find the exact value of each of the remaining 5 trig functions if the tangent of x is equal to 12 over 5 and the cosecant of x is negative. So the information that we're given to work with here tells us that the cosecant, which is the sine, is negative. Right? So we can eliminate the quadrants where the sine is positive. It's not in the first quadrant, it's not in the second quadrant. We're also told that the tangent has to be positive, okay, which eliminates the fourth quadrant because only the cosine is positive there. So we're working with, they're all positive, sine, tangent, cosine. So this angle is in the third quadrant. Now keep in mind, y'all listen, the vertex of our angles is what? Here. Now we don't know what that angle does, but the initial side is the positive x-axis and it ends up in the third quadrant. And the tangent is 12 over 15, which means the opposite side of this angle, 12 over 5. 5 squared plus 12 squared is 169. The square root of 169 is 13. This has to be negative 12, and this has to be negative 5. Why are they negative? Left and down are always negative. If you're not careful, you'll forget that in this particular instance of the tangent. Because negative divided by negative is positive. So the sine of x is equal to the opposite over the hypotenuse. That's negative 12 over 13. The cosine of x is equal to the adjacent side over the hypotenuse. And we're given the tangent of x. Tangent of x is 12/5. Cosecant x is the reciprocal of the sine, negative 13 over 12. Secant x is the reciprocal of the cosine, which is negative 13 over 5. And the cotangent of x is equal to 5/12. All right? Quiz on Thursday will cover the types of problems that we've looked at in this packet that you have in your hands. So make sure you are familiar with that. Your homework for tonight is actually not due until Thursday, and you will have all of tomorrow's class period to work on it. I wouldn't wait until then. You need to reinforce what we've done today, so you can do this, but it's section 2.3, 7 through 71 odd. That's not quite as many problems as it seems because if you look at your packet that I gave you, I eliminated some problems from the center part of that lesson. So it skips from like 35 to 55 in the packet.